Okay, so this video's purpose is to show you how a peptide bond forms and how we can join amino acids together to form a polypeptide. So we are going to first talk about the structure of an amino acid so we can understand how peptide bonds form. So first we start with the central carbon in the amino acid, and then attached to that central carbon is a hydrogen, and then on the left-hand side we have an amino group. And the amino group is a nitrogen with 2 hydrogens attached. And then on the right-hand side, we have a carboxyl group. And that carboxyl group is made of a hydroxyl, which is the OH, and then a double bonded oxygen. Now, attached to the central carbon, there's also what we call a variable side chain. Now, it's the side chain that makes each amino acid different from another. And so we have 20 different amino acids, and this R group is different on each one. So all amino acids have the amino group attached to a central carbon with a hydrogen attached, and then a carboxyl group also attached to that central carbon. So let's go ahead and see how we can build a polymer from amino acids. How can we build a polypeptide? So we start with one amino acid, and you notice the R group, that's the variable group that's different for each of the 20 amino acids. It also gives the amino acid its chemical properties. Is it going to be polar, nonpolar, etc.? Okay, so here we have a second amino acid. Now to join them together, we're going to remove an OH or hydroxyl group from the carboxyl group, and then we're going to remove a hydrogen from the amino group of the joining amino acid. So here, these two amino acids, when they bond together, are going to form a peptide bond. So you can see how by removing the OH and H2O, that forms water, and then the covalent bond between the carboxyl of one amino acid and a carboxyl group and the amino group of the other is going to be where the peptide bond forms. You will not have a peptide bond form between 2 carboxyl groups or between 2 amino groups. It's always between a carboxyl and an amino group. Now if I were to add a third amino acid here, so I would take this new amino acid, and again I would remove a hydroxyl or an OH as well as a hydrogen from the amino group, and then you'd have water form. So this process, if you've already learned it, is called dehydration synthesis. So we have joined 3 amino acids together here. So if you are ever having to identify 3 amino acids or how many amino acids are in a picture, you would either look at find a central carbon with an amino group and a carboxyl group, and then an R, and that would make up your one. And then here's our second one and our third. So here we have produced 2 water molecules by the process of dehydration synthesis, and that left us with 2 peptide bonds, each bond between a carboxyl group of one and an amino group of another. And so you would continue this throughout building of the polypeptide. Now this actually happens technically in the ribosomes, and which amino acids would be based on codons in the messenger RNA, but that's a whole other unit. I also want to point out that if we were to break apart or digest this polypeptide, it would be the opposite of hydrolysis. Well, not the opposite of hydrolysis, but the opposite is called hydrolysis, where we would add the water to that peptide bond to break it apart. So it'd be like the reverse. Okay, great job.